All right, let's give these ones a go. So question 13, let's look at A, C, E, and G. If I'm looking at A, left-hand side is what I'll start with. Pretend I've written it. Actually, I'll write it. Sine theta, cos theta. Hope you can read my writing. Sec squared theta. All right, if you have a look on the right-hand side, we're looking for cot. Cot, we know cot theta is the same as cos theta on sine theta. Right? It's tan theta upside down. So cos theta on sine theta. So if you have a look, we've already got a cos theta, so that's nice. We want that. But we want some stuff on the bottom so we can get rid of the sine theta on top. So what we'll probably do is change any of the weird ones. So cosec is 1 on sine, the reciprocal of that. So instead of writing cosec squared, we can write 1 on sine squared theta. And then you'll note that one of these will cancel. And if one of those sines cancel, you're left with a cos theta over a sine theta, which is what we want because we know that is cot theta. So that does equal the right hand side, and then you can say therefore, and then just write down the identity there, the equation, sorry. All right, so let's look at the C. Again, left hand side. If you note with C, we have a difference of 2 squares. So I'll show you. So if you look over here, it's only got squares, and on the left hand side we've got to the power of 4s. So think about it like this. We've got sine squared squared and cos squared squared. And when we have a look at the difference of 2 squares and factorize, we have, so here, if I had a squared minus b squared, we know that's a minus b, a plus b when you factorize. So think of a as sine squared a and b as cos squared a. So we're going to have sine squared a minus cos squared a and sine squared a plus cos squared a. But what is sine squared a plus cos squared a? That's one of our identities. That's our Pythagorean identity that's on our sheet. So we know that equals 1. So one lot of that bracket just gives us that bracket, and that bracket is what we were looking for. That is our right hand side. Okay. All right, let's look at E. So with E, we've got 1 plus tan squared on a 1 plus cot squared, and we want it to just equal tan squared. So what should we do? A couple of different things you can do there. Lots of different things, really. So which way do we want to go? Probably 1 plus cot squared. Well, how about 1 plus, because I know it better, we know that 1 plus tan squared x is equal to sec squared x. That's one of our identities, our Pythagorean identity. So what I could do is I'll write my line down first. So there's my left hand side. So I might change the top to, well actually no, I won't do that. What will I do? All right, so bit of a long way round, but anyway. So what I could do is, as cot is 1 on tan, I could keep it as 1 on tan. So this is going to become 1 on tan squared x here. Now if I make a common denominator for the denominator, so if I make so I've still got 1 plus tan squared on top. So if I make a common denominator of tan squared x, what do I have here? I have a tan squared on a tan squared. So that gives me the 1 plus I have the 1 here. Okay, so I actually have 1 plus tan squared x, and then this is divided by this fraction. So I'll put that times by the reciprocal of this fraction. So I just tip it upside down here. Yeah, so just remember your fraction. So if you're dividing by a fraction, same as timesing by the reciprocal of that fraction. And you'll see we've got the same thing here. We've got a 1 plus tan squared and a tan squared plus 1, which is the same. So now they cancel. And all you're left with is a tan squared x, which is what we want. So it's just, again, just one way to do it. Apologies, I could have gone this way, but I didn't. So yes, apologies for leading you astray there. Okay, so that was just using the reciprocal of cot. All right, let's look at the last one. So G. So we've got two things that we're adding, and there's one thing here. So we really want a common denominator. So let's have a look at our left-hand side and make a common denominator. So if we times each of these denominators by each other, well, then we'll have a common denominator. So our common denominator will be 1 plus sine theta, 1 minus sine theta. And when we do that, what do we get on the top of this fraction? We'll have to times it by 1 minus sine theta, so 1 times 1 minus sine theta. And this one, we would have to times by 1 plus sine theta. There we go. So what have we got on top? We've got 1 plus 1 is 2, and then we've got a minus sine theta plus sine theta. So they cancel. These two will cancel each other out. So it's just a 2 on top. On the bottom, let's see what we've got. We've got a difference of two squares. So 1 plus sine theta, 1 minus sine theta is 1 minus sine squared theta. Okay, 1 minus sine squared theta. But we do know that sine squared theta plus cos squared theta equals 1. So 1 minus 1 minus sine squared theta equals cos squared theta. So that's just 2 on cos squared theta. And so 1 on cos squared is just sec squared. So that's the same, using reciprocal identity, is the same as sec squared theta. So we do get the right hand side there.